So they all cross at 0, 1. And what? As B gets smaller, it gets steeper? Is that what you said, Monty? But this says as B gets bigger, the graph gets steeper. And this says as B gets smaller, the graph is steeper. Oh, so you think it has something to do with the fact that these are bigger than 1 and these are between 0 and 1? Interesting. Who had set 3? What you got right here? Set 3 was kind of tricky, so if you had set 3, I apologize to you. This is what we need to have a discussion about real quick. This number right here. I know that for your whole life people have told you that E is a letter, and that is true. That's why they've told you that. But E is also a number. Okay? It was invented by a guy named Leonard Euler. It's long and boring. Not really. It's not really boring. It's pretty cool. Well, like math cool, right? But it is a number. It's even on your calculator. Like, it's even stored in your calculator. See right here? Right there? E raised to the x power. It's a number that, like, we've used a lot. We use a lot. And so, as mathematicians, and so they even have it stored in our calculators. Okay? So, what do you have here for this, for y sub 1? 2e to the x. And what about this last one? 0.5 e raised to the x. Okay, so what do the graphs look like? Is that good? Close-ish? You better be nice. I'm a math teacher, not an art teacher. I do my best. Rude. Okay. How did these graphs compare? What did you say just a second ago? Translate. Why'd you say to the... Which one of these is which, by the way? This one is y sub 1? Like that? Are you really sure about that? You are? You're not sure? Or that's not right? Which one is it? So that's not right? Is that what you're telling me? So which one is this? Y sub 2? And this is y sub 1? Does that make more sense? I know. It's okay. I just want us to all be confident that we're right. That's why I asked if you were sure. So you think this is a translation? Are these all the same shape? If y sub 3 is a stretch, why wouldn't 2 be a stretch also? You know what I'm saying? I'm asking. I mean, I know. I want you guys to figure it out. You're telling me it looks like a translation, right? What normally causes a translation? Thinking back to all the other transformations we've done before. What causes a shift to the left or right? Adding or subtracting. Are we adding or subtracting anything? What are we doing? We have a multiplier, right? Isn't that what you just said? Okay, so do we need to fix this or leave it alone? What does a multiplier usually cause to happen? Yeah. Vertical or horizontal? How many times have we ever dealt with the horizontal stretch or compression? Never. So it's going to be a vertical stretch or compression. Can you see my L? Okay. Who had set 4? Okay. What'd you get right here? .5x? Oh, to the x, okay. And then what'd you get here? Guess if I'm staying consistent with the way the answers are. Wait, does it matter if I have this on the inside or the outside? That's something we probably need to look into, isn't it? Okay. Okay. Good discussion. I'm not going to tell you if you're right or wrong. I just want you to think about it. Not yet, anyways. We'll talk about it later. Okay? So, what do the graphs look like? Like that? Okay. So, how do they compare? Which one's flipped? Which one is which? This one here is 2? Like that? So what do you think made this one flip? Oh, so negative flips? Is that what you said? I'm writing your words. We can always go back and adjust them later. I'm just writing your words. What happened to these two? What are the difference in these two? Oh, like different multipliers here? So what did that cause? Okay, a stretch. Wait, what's causing the stretch? The A, right? Or compression, right? Depending on which way we're going. But it's because of A, right? Now, Joe, you had a question? Oh, I'm not being very careful how I graph right now at all. I know it has the axes and stuff. I'm just getting close right now, just because excuse me, it doesn't have intersections. It's really hard to see that way. We'll talk about that, how to tell where it crosses the graph. We'll talk about it in just a minute. Deal? Okay. Who had set 5? Okay, so what's different about set 5? What did you get here? What does K typically do? So it's a shift up or down. Did it turn out the same way here? So we think K causes a vertical shift? Wait, didn't K cause a vertical shift last time? So it's doing the same exact thing in a new parent function? Oh my gosh. What about set 6? Wait, this is 1? Oh, this is a negative 1. Okay. Okay. So what do these look like? Ish. What was the same in this one? The K's and the B's, right? So what changed? The A. So what does A cause? So A causes a stretch, compression, or flip, says Jacob. Do you agree with him? Remember, I'm just writing your words. We can always fix it later. Is he right, though? Yeah. Wait, where's the asymptote here? I know it didn't draw very well, but can you see an asymptote? Like right here? Oh my gosh, where is that? Like at K? Oh my gosh. Let's summarize what we figured out. Okay? When A is greater than 1, what happens? Look back if you need to. Uh-huh. Very good. Vertical stretch. Wait, hey, wait, isn't that what it was before? Yes. What if A is between 0 and 1? Vertical compression. What if A is less than 0? Over what? X-axis, right? It reflects over the x-axis. So what if B is greater than 1? This is new, for the record. This is new. What if B is greater than 1? Look back at all the B's. What do you mean by that? Back at number 1. Okay. What are we comparing here, though? We're saying B is greater than 1 or B is between 0 and 1. So if B is greater than 1, it's shh. And if B is between 0 and 1, it's like shoo. Can we use words that are a little closer to math related? Ascending and descending is fine. I know what you mean, but how about increasing and decreasing? Is that okay? The graph increases. Do we need to say from left to right? Are you going to know what I mean if I say LR, left to right? Lr. And this one's decreases? Okay. What about K? So if K is greater than 0? Okay, I promise I'm not making fun of you. I promise I'm not. But we're never ever going to have a vertical shift to the right. Because remember, vertical's up or down. Okay. Vertical shift up. And when K is less than 0? What about Y equals K? Oh, what kind? Horizontal asymptote. Very good. Okay? So let's see if we can pick some of this stuff out. What's happening in this graph right here? Is A less than 0 or is A greater than 0? It's less than 0. Why is it less than 0? Okay. Is B greater than 1, or excuse me, less than 1 or greater than 1? It's greater than, because if it was flipped over, it would be increasing, right? Okay. And what about K? It equals 0, right? Because it's a little tricky because there's no markings on this graph, but that's probably 1 right there, isn't it? Okay. And guys, that's the thing about exponential, the parent function. I don't know if you'd be able to tell this, because see, exponential is kind of tricky because there's not really like one parent function. Because A can be something and B can be something. Or there's no A and there's just a B, but B could be 2 or 3 or 9. Okay? But regardless of what that is, what happens when x is 0? Anything to the 0 power is 1. Always, right? Okay? And so the parent function is always going to go through that point, 0, 1, or 0, negative 1, depending on if it's decreasing right there or not. Okay? So that's a good hint to be able to tell if there's a multiplier or not. So what about this one? Is A less than 0 or greater than 0? Peyton, why'd you say greater? Remember A, okay, it is greater than 0 because it's not reflected. Okay, that's a good point. Okay? Because it was just asking less than or 0 or greater than or 0, not anything about a stretch or a compression, right? Okay. So what about B? Is it less than 1 or greater than 1? Greater than 1. Why'd you say that? Because it's increasing. And then what about K? Why do you say greater than 0? Because it's shifted up. Like there's an asymptote right there, isn't there? Okay. And what about this one? A? Well, one of those is right. Which one? Why? It's not reflected. It's just decreasing, right? And so that should tell us something about B. It's less than 1. And K? Less than 0? Because there's the asymptote down there, right? Okay. What happens if B equals 0? Well, we need a table, right? Okay. So here's what's going to happen. These two problems right here, A, B, C, and D. So this problem and this problem, those are the two I'm talking about. But there's actually 4 little mini problems in there. Those are going to be your homework problems for tonight. I really want you to think about those. They are word problems, so I would like your answer in a sentence. Capitalization, punctuation, grammar, spelling, all that stuff. Okay? Look real quickly at ants. Not the actual ants, because there's actually not any ants in here. I'm talking about the worksheet called ants. Okay? This is your other page of homework for tonight. Just word problems. I would say practical application of exponential functions, but we're probably not going to be counting the number of anthills unless we're a scientist that is studying ants. Okay, so being realistic in several ways, right? It can be used, but we may or may not use it. All right? Any questions about this? Ask me later if you do. Okay?